Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic and troubleshooting procedures for DTC P0455, which indicates a large leak in the EVAP system of Honda Accord models manufactured between 2012 and 2017. The EVAP system, or Evaporative Emission Control System, prevents fuel vapors from escaping into the atmosphere, thereby reducing emissions. A large leak can be caused by various issues, such as faulty fuel fill caps, damaged vapor lines, or defective valves. When the system detects it cannot maintain proper vacuum or pressure, an error code P0455 is stored in the vehicle's PCM, warning of potential emission leaks. Proper diagnosis involves following specific steps to pinpoint the faulty component without causing damage to the EVAP system. Correctly solving this DTC ensures optimal vehicle performance, compliance with emissions regulations, and prevention of potential fuel tank damage. This step involves a comprehensive visual inspection of the fuel fill pipe and vapor return pipe for any signs of damage, cracks, or loose connections. Proper sealing at the fuel fill pipe ensures emissions are contained when fueling or driving. Any damage here could cause large leaks. The fuel tank unit base gasket and the tank itself are also inspected because degradation can lead to vapor leaks and trigger DTC P0455. Replacing or repairing these parts if damages are found will be necessary. Once the parts have been repaired or replaced, a final system verification is performed to confirm the leak has been eliminated. After repairing the identified issues, the vehicle system needs to be reset to clear codes and learn its idle parameters again. Turning the ignition off, reinstalling all removed parts properly, and then turning it back on ensures that the system can perform its diagnostic functions correctly. Using the Honda Diagnostic System to reset the PCM, Powertrain Control Module, clears the fault codes including DTC P0455. Following the reset, performing a PCM idle learn procedure helps the vehicle's idle control system function optimally. Finally, conducting the EVAP system function test verifies if the repair has successfully eliminated the large leak, confirming the troubleshooting process is complete. Preventative measures for avoiding recurrence of DTC P0455 include regular inspection of the fuel system, especially the fuel fill cap, vapor lines, and associated valves. Proper tightening and timely replacement of damaged caps prevent vapor leaks. Routine visual checks of the EVAP hoses, canisters, and valves can catch potential issues early, reducing the possibility of system failure. Maintaining the integrity of the EVAP system contributes to efficient vehicle operation, meeting emissions regulations, and preventing costly repairs. Keeping these components in good condition supports long-term vehicle health and helps identify problems before they trigger diagnostic trouble codes. In conclusion, DTC P0455 indicates a large leak in the EVAP system that can be caused by several factors, including loose or damaged fuel fill caps, cracked vapor lines, or faulty valves. Following a systematic troubleshooting process as outlined ensures a thorough diagnosis, from simple fixes like tightening the fuel cap to replacing major components like the EVAP canister or vapor lines. Using proper diagnostic tools like the Honda HDS, vacuum gauges, and pressure testers is essential for accurate troubleshooting. After repairs, system reset and verification are critical to confirm the issue is resolved permanently. Maintaining the EVAP system through regular inspections greatly reduces the risk of future leaks, ensuring the vehicle remains environmentally friendly and compliant with emission standards. The first step in diagnosing a DTC P0455 involves inspecting the fuel fill cap installation. A proper seal requires the cap to be tightened until it clicks, indicating it is securely in place. The cap should also turn approximately a quarter turn after reaching the click point, confirming correct engagement. A loose or improperly installed fill cap can cause the vehicle's diagnostic system to detect a large leak due to vapors escaping from the fuel system. If the cap is not tightened correctly or is damaged, replacing or properly tightening it can resolve the error. After correcting the cap, a repair verification should be performed to ensure the DTC clears, confirming the fix. The second step involves examining the fuel fill cap seal and the mating surface of the fuel fill pipe. The seal must be intact and free of damage to prevent vapor leaks. Damage or missing components may compromise the seal, allowing vapors to escape and triggering the DTC. Additionally, the tether cord that connects the cap to the vehicle should not be caught or jammed under the cap, as this can interfere with proper sealing. If any damage or issues are found during this visual inspection, replacing or repairing the faulty parts is necessary. Confirming the integrity of these components and performing a repair verification afterward will ensure the EVAP system is sealed properly. This step involves inspecting the fuel tank vapor recirculation tube, which routes fuel vapors from the tank to the engine for combustion. Make sure the ignition is turned off to safely access the components. Visually examine the tube for poor connections, cracks, or damage that could cause leaks. The vapor recirculation tube plays a crucial role in controlling vapors and maintaining system integrity. Damaged or disconnected tubes can create large leak conditions, leading to the P0455 code. If issues are found, replacing or repairing the vapor recirculation tube will be necessary, after which a repair verification should be performed to confirm the problem is resolved. In this step, the EVAP canister purge valve is tested for leaks by disconnecting the vacuum hose from the valve itself. A T-fitting and vacuum pump are connected to apply a controlled vacuum of approximately 15 millimeters of mercury or 0.6 inches of mercury. The system is then monitored to see if the vacuum holds for 1 minute, indicating the valve is sealing properly. If the vacuum leaks down quickly, it suggests a leak in the purge line or a faulty purge valve itself. The integrity of the purge valve is critical because it controls vapor flow into the engine. Replacing a leaking purge valve and performing subsequent checks can help eliminate the large leak detected by the system. The fifth troubleshooting step focuses on verifying the EVAP system's operation using diagnostic tools like the HDS Honda Diagnostic System. The ignition is turned on, and any stored DTCs are cleared to assess whether the code reappears, indicating an ongoing issue. The EVAP system is then tested via HDS's function test mode to simulate system operation and check for proper response. If the system passes the test, it suggests an intermittent problem. If the code reappears or the test fails, further inspection of sensor connections and circuit integrity is necessary. This step confirms whether the system's electronics or sensors contribute to the large leak warning. This step involves isolating the EVAP vent shut valve, which controls venting of vapors from the canister. The vapor recirculation hose is disconnected, and the canister port is plugged to prevent loss of vapors during testing. Applying vacuum to the system with the engine in on mode allows for testing the valve's operation. The Honda Diagnostic System HDS is used to select the EVAP CVS on mode, activating the vent shut valve. Monitoring voltage signals from the FTP, fuel tank pressure sensor, helps determine if the valve responds correctly. A voltage increase more than 0.2 V indicates proper operation. If not, the vent shut valve may be faulty, or there could be an issue with the vacuum line. This step tests the EVAP canister vent shut valve by turning it off command via HDS. The fresh air hose connected to the canister is removed and the vent shut valve port is plugged to connect the system for testing. Vacuum is applied and the FTP sensor's voltage is monitored over 1 minute. If the voltage increases more than 0.2 volt, the vent shut valve is functioning correctly, allowing proper venting. If the voltage does not increase sufficiently, it indicates the vent valve or its line may be defective. This diagnosis helps locate whether the fault resides in the vent shut valve or the purge line. The 8th step emphasizes visual inspection of the EVAP purge line and canister. The purge line, which connects the EVAP canister to the engine intake, must be free of cracks, disconnections, or damage that could lead to vapor leaks. The EVAP canister itself should also be examined for cracks, damage, or signs of contamination. Damage in these components can circumvent the system's ability to contain vapors, leading to a large leak code. Replacing damaged lines or the canister, followed by functional verification, ensures the system's integrity, capable of preventing emission leaks. Please like and subscribe to the channel. See you next time.